Welcome. We are going to review how to do a one sample t-test. So a one sample t-test is when you are looking at your data set and there's like a variable, let's say it's going to be highway miles per gallon. And you want to know, is this a lot different than what maybe the average is out there, the national average for all cars? So that would be a hypothesized mean that you would find somewhere in the literature. Now, I've used this in my own personal research. I did a study on perfectionism, and I wanted to know if my students in my study had higher perfectionism scores than what was found in a past study. And so I just found the mean from the past study and did a one sample t-test. So this might be of interest to you. So here's what I want to know. I want to know if the highway miles per gallon are different than just the average in the nation. So first I got to go through my assumptions, and I'm going to assume that I am working with a random sample here. So I'm assuming that all these cars in this data set were chosen from a population in a random way, maybe using a hat or a table of random numbers, but this data is from a random sample. The second assumption is that this data here is normally distributed, especially for highway miles per gallon. So I'm going to go to Analyze Distribution. I'm looking at my variable of highway miles per gallon. And so this gives me my descriptive statistics. So as I look at this, I'm a little bit concerned just by looking at this histogram that it could be a little bit positively skewed. You see how there's skew in the skinny in this positive end? So, so I really should check out if this is normally distributed. Well, skewness is supposed to be between a -1 and a +1, and it's just outside that realm. And so if it's between a -1.5 and a 1.5, then I really should look at kurtosis as well. Now, as I look at kurtosis, I'm looking to see if it's between a -2 and a +2. It is, so therefore, I'm okay with my normal distribution assumption. I need to report and write the skewness and kurtosis here, especially since skewness was a little bit off. So I'm okay with that second assumption. The third assumption, that's usually about homogeneity of variances, I don't need to worry about because I'm only looking at one sample, just my data set. I'm not doing any comparisons with a whole other column of numbers, just this like one number, this one mean score that I know from the literature. So my assumptions are met. Now I am ready to do the test. So I will go to this little red arrow here. I will go to test mean, and I enter the hypothesized mean. Now I looked it up on Google, and I go 26.4 is what the average highway miles are in the world, or just the average that's out there. And it shows me the results of my one sample t-test. Now, I've really got to go back and think, well, what exactly was my null hypothesis? And that is that there would be no statistically significant differences between my highway miles per gallon versus the national average. So this is what I need to really look at. Now, this t statistic is what the t-value is, and what, if you remember from the t formula, it's basically at the top part of the numerator, it's a mean minus a mean, and then it's divided by a bunch of stuff. But basically, is there a big difference between these means? Now, a t-value of a 4.9 is pretty big, and so you're probably wondering, what makes a big t? Well, it depends. T distributions, these little bell curves of T's, T distributions are based on degrees of freedom. Now, degrees of freedom, that has to do with the sample size, and in a one sample t-test, the degrees of freedom is n minus 1. And so if you look here, we have n, 93, n minus 1 is 92. And so this curve that we know of for the t-test is based on that, and that's what the T number is based on. So this T value is what I will report. Now, is it statistically significant? Are there differences? Oh, yes, there are. So if you are doing a non-directional null hypothesis, that means you're just saying there's no difference. You're not worried about which direction, which one's higher, which one's lower. You just want to know, are there differences or not? You look at this one right here. All right, this is the non-directional t-test, and it is below my set alpha of a 0.05. Now, I should have set my alpha before doing this test. I chose a 0.05 because my sample size is 93, which is below 250. If I had numbers 250 or more, I would have chosen a p-value of a 0.01. So I can tell the world this is a statistically significant difference. My mu score, I have higher miles per gallon in this data set than the national average, and I would tell everybody that. Now, you could have set a directional null hypothesis at the beginning. So your directional null might have been, there is my data set is not higher than the given national average. And so the alternative hypothesis would be my data set, like the hypothesis that I myself as a researcher think in my head, my alternative hypothesis is my highway miles per gallon are higher than the national average. If that's what I thought in my head, I would have used an upper-tailed t-test. And that too is also significant. You see, this is the upper-tailed t-test. And yes, indeed, not only are there differences, but mine are higher. That shows me the direction. Now, if my alternative hypothesis as a researcher, what I was thinking was mine are lower than the national highway miles per gallon, then I would have had to look at this one, the lower-tailed one, and that would be incorrect. So I would have to retain my null hypothesis. So this is what you're looking at here. Now, because there is a statistically significant difference, I want to know how big are those differences. So what I would do is I would use an effect size calculator, and I'll do that in just a minute. But before I get off of JMP, I want you to see how to calculate the power. So I click on power animation, and you will see that the power is big. The power is 0.99. There is a 99.8% chance that I am correct in rejecting my null hypothesis. The way all of this worked out with the data, with the numbers, I can be very confident that rejecting the null hypothesis was indeed the right thing to do. This power was very high. So you need to look at the power. All right, I'm going to pause this for a moment and get to the effect size. Okay, so because I found a statistically significant difference, I need to report the effect size. And to do that for a t-test, you would use COND. And so it's a really easy formula. You could actually do it by hand. You're basically looking at mean differences, but you can use a calculator online. I just Googled this, found a one sample t-test calculator for effect sizes. So put in my sample mean that came out of JMP, my sample standard deviation that came out of JMP, then the hypothesized value, the one that I found in the literature. I clicked calculate, and it shows me the D was a 0.51. Now, how do I know if that's big or not? Well, I have read my Hatcher text, and I have looked at it and know that this is a moderate effect size. So basically, it's one thing to see, yeah, there's statistically significant difference. Reject your null hypothesis. But how big is the difference? That's what the effect size says. It tells you the strength. It tells you how big. And so it's moderately big. My samples highway miles per gallon were indeed I forgot if they were bigger or smaller. Bigger. It was higher than the national average. So that's how you get the effect size. All right, so that's the easy one sample t-test. Have fun.